All right, so we're going to start or finish the notes for 5.4. This is part 3. So solving some basic log equations. So now we've graphed the log functions. We understand that they're inverses of the exponential functions, and we know that their domains and range flip from the exponential to the log. So now let's go ahead and let's solve some log equations. So right here, when solving simple log equations, follow these steps. Isolate the log if possible. So the log expression, you get that alone. Change the log to exponential form. So using that definition, you're going to change that. And then you're going to, it says use strategies you learned in 5.3. Well, because then you'll have an exponential function. They're going to solve it by using anything that we did to solve exponential functions from earlier. So here we go. What does it say to do first? It says to isolate the log part. Well, the log part is isolated already for this one. Now use your definition. 2 to the third power equals 2x plus 1. And now you just solve. So this would be 8 equals 2x plus 1. So 2x is equal to 7. X is 7 halves. Is solving that equation. This one again, the log is already alone, so I can immediately do x to the third power equals 343. This is not technically an exponential equation because the exponent does not contain the variable. So here you would simply cube root both sides, and I think the cube root of 343 is 7. This one, we have to isolate this log part, so we need to get this guy alone. So we'll subtract 6. That's just x. Divide by -1. That's going to give us the log of x equals 3. Now remember, this is a common log because there's no base, so it's an understood 10 there. If I change this to the exponential, 10 cubed is equal to x. So x is going to be 1,000. All right, look at this one. The log part is alone. Okay, what is the understood base to this log? It's a natural log, so it's just simply e. So e to the second power is equal to x. Now, if they ask you to leave your answer exact, you would just leave it as e squared. If they tell you to round it, you would actually go ahead and in your calculator, square the e. If I square the e, I'm going to get 7.39. So kind of check the answers in the back of the book to figure out what they want you to do. Over here, we have to isolate the log part there. So you can see the first thing we're going to do is subtract the 5. So that's going to give me -7. I'm going to divide by 7. So log base 6 of 4x is equal to -1. Let's use our definition, change it to its exponential. 6 to the -1 power, that's 1/6, is equal to 4x. And if I multiply both sides by 1/4, my answer for x in this case is 1/24. Last one here, well, let's see. It would be 6 to the 5x plus 3 power is equal to 36. Because the log part was already alone, so 6 to this power equals 36. This is an exponential equation. Let's get the bases the same. So 36 is 6 squared. Once the bases are the same, set the exponents equal to one another. And solve. You should get negative 1/5. So again, they're going to get more complicated soon, but for right now, that's what you want to do. So those are all logs, LOGs. Now let's talk about how we would do it with a common log, which we actually already did. We just made that base was a 10, or natural log with a base of e. So if you look at the steps, it says isolate the exponential part. So notice that these are exponential functions. They're not log functions. So we're going to isolate the exponential part. Then it says change the exponential into a logarithm, and then use your calculator. So look at this one. The exponential part is already alone. There are a couple of ways to do this. One of these, so I'm going to actually use a slightly different method for A and B. One way to do this would be to, as soon as you see the A or the E, take the natural log of both sides. So, what is the natural log of e to the x? As long as this base, now listen carefully, as long as this base is the same as this base, see how these two things are the same? The natural log of e to the x is simply x. It is actually a property that we're going to have in another section, but I'm giving it to you early. If I can get this base the same as this base, then those basically cancel out. The answer is just x equals the natural log of 7. So now you would go to your calculator and plug in the natural log of 7. It doesn't say where to round to, so I'm just going to round to the nearest hundredth. 1.95. But remember, you can pause anytime you want. So let's look at this one. We have to get rid of the 2. So e to the 3x equals 3. So now again, let's go ahead. Let's take the natural log of both sides. So the natural log of e to the 3x is equal to the natural log of 3. Now again, what did I say? This base is e. This base is e. That left-hand side is simply going to turn into a 3x equals the natural log of 3. Let's get the x alone by dividing both sides by 3. Now you can go ahead and plug it into your calculator, and the natural log of 3 divided by 3, you're going to get 0.37. So again, whenever you see the e, the best thing to do is just take the natural log of each side. Let's do this one. The natural log of e to the 5x minus 1 power is equal to the natural log of 9. Bend this up. Again, since that has a base of e, this whole left-hand side collapses down into 5x minus 1 equals the natural log of 9. Let's get the x alone by adding 1. So 5x would equal the natural log of 9 plus 1. And then finally we'll divide by 5. Now this is quite a hefty thing to plug into your calculator, but you should be able to do it. Do it on your own. I'm going to do it and we'll make sure we get the same answer. So the natural log of 9 plus 1. And then I want to take that and divide by 5. So I'm getting 0.64. So you guys make sure that you can get that as well. Okay, so this one, we don't have any e's, but we have a base of 10, so we're going to end up taking the common log, so we'll be able to use our calculator. So the first thing that we have to do is isolate the exponential part. So we've got some work to do, so we're going to subtract the 1, divide by 4, now we're not going to take the natural log of both sides, we're going to take the common law of both sides. So if I take the log of 10 to the 2x equals the log of 5. Now remember, this is a base of 10. Same thing that happened with the e, since these two bases are the same. This left-hand side condenses down to 2x is equal to the log of 5, which means x would be the log of 5 over 2. And remember, when we talked about common logs, I said that's the LOG button in your calculator. So just take the log of 5 and divide it by 2, and you should be getting 0.35. Check that to make sure you can get that. And last but not least, let's do this one. We're back to the natural logs again. So I'm going to add 2, divide by 3, take the natural log of both sides, now again, remember what happens because this has a base of e. This left-hand side collapses down into 2x plus 1 equals the natural log of 4. Let's get the x alone, so let's subtract 1 and divide by 2. Okay, so let's plug that into my calculator. So I'm going to do the natural log of 4. I'm going to take and subtract 1 from that, and then I'm going to divide that by 2, and rounding to the nearest hundredth, I'm getting 0.19. All right, I believe that that is the end of these notes. See you in 5-5.